All right, let's jump right in. Today, we're going to talk about a huge technological shift, one that's happening as we speak, and it's set to change, well, pretty much everything we know about digital security and the internet itself. So let me start by asking you a question, and it's a pretty intense one. What if every single secret you've ever sent online was about to be exposed? Because right now, the digital locks that protect our bank accounts, our private messages, all of it, they're facing a massive threat. A completely new kind of computing is coming, and it basically holds the master key. And here's the kicker. This isn't some far-off sci-fi problem. It's happening right now. It's a strategy called harvest now, decrypt later. What that means is that bad actors are already intercepting and just stockpiling our encrypted data, hoarding it. They can't read it yet, but they're betting that in the near future, they'll have the quantum computers to unlock all of it. This is a ticking time bomb, and the fuse has already been lit. So what is this master key we're talking about? Well, it's the quantum computer. And to really get what's going on, both the threat and the incredible opportunity, we got to break down what makes these machines so radically different from anything we've used before. Okay, so every computer we use today, from your phone to a supercomputer, is built on bits. And a bit is super simple, right? It's either on or off, a 0 or a 1. That's it. A quantum computer, though, uses something called a qubit. And this is where your brain has to bend a little bit. Thanks to a wild quantum principle called superposition, a qubit can be a 0, a 1, or both at the same time. And that single difference, that ability to be in multiple states at once, is the secret sauce. It unlocks a level of parallel processing power that's just hard to even comprehend. Here's a good way to picture it. Imagine you're looking for one specific card in a massive, massive deck. A normal computer has to go through it one by one. Flip a card? Nope. Flip another? Nope. You get it. A quantum computer running an algorithm like Grover's can essentially see all the possibilities at the same time. It's not just a little faster, it's a fundamentally different way of solving the problem. It finds that card in exponentially fewer steps. And that brings us right back to the threat. See, our modern digital security is built on math problems that are incredibly hard for even the fastest supercomputers to solve. But for a quantum computer running something called Shor's algorithm, those problems are trivial, like laughably easy, which means the very mathematical foundation of our secure internet is basically set to crumble. Okay, so that sounds pretty scary, I know, but the story doesn't end there. The same brilliant people who identified this threat are now in a global race to build a new kind of digital lock, a quantum-proof lock, to create a whole new foundation for a secure future. And they're basically coming at this from two main directions. First, you have post-quantum cryptography, or PQC. You can just think of this as better math. We're designing new encryption based on math problems so fiendishly complex that even quantum computers will struggle with them. The second path is quantum key distribution, or QKD. And if PQC is better math, QKD is better physics. It uses the actual laws of quantum mechanics to secure communications. The cool part is, if anyone tries to eavesdrop on the key exchange, the very act of observing it changes it, and you instantly know you have a listener. And this better math stuff isn't just a theory anymore. It's becoming reality. In 2024, NIST, the U.S. National Institute of Standards and Technology, officially finalized the first set of these new post-quantum standards. So algorithms with these funky names like ML-Chem and ML-DSA are now being rolled out to protect us from both today's threats and tomorrow's. And the better physics approach? That's moving full steam ahead too. QKD is being developed for everything from the next generation of 5G networks to secure satellite communications in space. I mean, just think about that for a second. Security that is literally guaranteed by the laws of nature. It doesn't get much more robust than that. Okay, so let's shift gears a little bit, because the story of our quantum future, it isn't just about defense. The very same technologies that are creating this threat are also paving the way for a much smarter, faster, and more responsive internet. And what's at the center of it all? Artificial intelligence. I really like this quote because it captures the proactive side of all this. We're moving beyond just building walls. We're making the network itself intelligent. Imagine a network that can anticipate a traffic jam online before it even happens and just seamlessly reroutes everything. That's the kind of power we're talking about. Now, this diagram looks pretty complex, I get it. But the takeaway is actually really simple. AI isn't just going to be another app running on the network. It's going to be the network's central nervous system. It'll be woven into every single layer, from the hardware all the way to the user experience, constantly optimizing, managing, and securing the entire system. So how does this actually work in practice? Well, you can kind of break it down into 3 simple steps that just repeat over and over. First, the AI will sense everything happening on the network in real time. Then it uses all that data to predict what's going to happen next, where demand will spike, where problems might pop up. And finally, it will allocate resources, shifting spectrum and power around intelligently to make sure everything runs as smoothly as humanly or, I guess, artificially possible. So what does this all add up to? When you combine quantum-level security with an AI-powered brain, what does that future actually look like? Well, let's get a glimpse of the digital world we are building right now. Let's start with raw speed. Researchers have already demoed a 6G chip that can transmit data at 100 gigabits per second. To put that into perspective, that is over 300 times faster than the typical 5G you might get on your phone today. The leap in performance is absolutely staggering. And as you can see from this timeline, the move to 6G isn't just about making things a bit faster. It's a total paradigm shift. We're moving from just connecting things to a world where our physical and digital lives are completely intertwined. This is the tech that enables things we've only seen in movies, like holographic telepresence or truly autonomous robotics. Now, it's really important to have a quick reality check here. We are in what experts call the NISQ era. That stands for Noisy Intermediate Scale Quantum. The keyword there is noisy. It means today's quantum computers are powerful, yes, but they're also incredibly delicate. They're super sensitive to tiny disturbances from their environment, which causes errors. So scaling these things up is one of the biggest engineering challenges of our time. We have the map, but it's still a long road ahead. So we end up right back where we started with a big question. This combination of quantum and AI, is it a threat to our present, or is it the key to our future? Well, the answer is it's both. It's a true double-edged sword. It has the power to shatter the digital world we've built, but it also has the power to create a faster, smarter, and more secure world than we can even imagine. The real challenge, and the opportunity, is to build the lock before that master key is fully forged.